I'm actually going to be building on what Paul was just talking about. He was talking about systematic reviews. He was talking about ways of going through information. And I may be part of the Monty Python flying circus here, jumping out and saying no one expected the Spanish Inquisition. What I hope to do here is explain a couple of things that I think are fundamental in that particular way of going about a systematic review. But first, let me make a disclaimer. And the disclaimer is this: I'm not a nutritionist. You are nutritionists. You are in product development looking at different ways of bringing different kinds of molecules to human health in our diets. Where I come from is pesticides. And I've done just about every kind of toxicological research you could possibly do, from fundamental LD50 studies all the way through doing very complicated mode of action studies. And in that context, I've always thought about xenobiotics, or chemicals that you don't necessarily want to have in your diet, and what does that mean to human health? The difference, of course, with you is that you're talking about things that are perhaps naturally found in our diets and wondering about what the quantity in our diets really means as far as human health. So when you bring those two kinds of thinking together, me as a toxicologist and you as nutritionists, we start thinking about what that really means in the context of human health and how we go about a systematic way of producing information that we can make judgments on human health and safety. So what I hope to do this morning is give you a very quick rundown on what the traditional method is for doing risk assessment. And I understand from talking to a number of different people that you are not practicing risk assessors necessarily. Some of you are, but many of you may not have the same familiarity that we have with how we go about risk assessment. And then I hope to bring to your attention a methodology that we use called RISK21, which is a HESI-led organization effort that has put together the next way of going about a systematic way of looking at the human health and safety aspects of chemicals in our diets, whether they're naturally found there or they're put there by the synthetic chemicals that we create. So when Heather contacted me some time back about coming and giving this talk, I started thinking to myself about, well, I'm constantly thinking about chemicals in our diets, in our air, and in our water. Well, what do you think about when you think about chemicals that are naturally found? And I started thinking about things like vitamin D and vitamin A and vitamin C and how much we take. Should we take more? Should we take less? And then I got thinking about caffeine, which is one of my favorite subjects, of course. I don't know about you, but I've had to have plenty of it this morning to get going. And then I got treated to a wonderful set of presentations at the Toxicology Forum. And Tony Mattia was there and gave a delightful presentation on caffeine. And I started thinking to myself, well, how do you go about thinking about caffeine in a toxicology risk assessment sense? And Tony, I think you probably remember me getting to the microphone after everyone had given their talks about adverse effects and panic attacks and jittery nerves and alertness and so forth. And I said, well, what's the no effect level for caffeine? Because that's the way we look at it in chemicals, after all. We always go through and we do lots of toxicology tests in animals and we find a no effect level. Well, what's the no effect level for caffeine? Well, I think to be fair to Tony, the answer was, well, that's not really how we approach it. And that's true. And that's what I'm going to be developing in this talk today, is that your approach to naturally found ingredients in food and additives in food is a bit different, but the methodology can be the same, and the systematic thinking needs to be the same. So I got back from the Toxicology Forum after hearing about caffeine, and I started fishing around to get some information on caffeine, and found this on the FDA website, that in fact, unfortunately, someone had taken pure powdered caffeine. I thought, woohoo, let's put that in our coffee in the morning. And I thought, I didn't even know this was made. What have I been missing all my life? But then I realized that this is 100% or nearly 100% caffeine. And this is material that people are going to use as a stimulant, and certainly there are a lot of different things that point to at least what I would consider to be adverse effects: erratic heartbeat, seizures, death. So this goes well beyond what I'm looking for in just a little bit of alertness, or perhaps even to the point of getting a bit jittery. But I'm going to trade off those negative parts for the benefits of caffeine. Well, then I started fishing around a little bit more, and I found something even far more interesting as a systematic review and a way of looking at toxicology and so forth. And that was at this place called the caffeineinformer.com. And it was called Death by Caffeine. Now there's an endpoint for you. So I went to their calculator, and you can actually calculate, if you go across the street to Pete's Coffee and put in your weight, you can calculate how many cups of coffee before you croak. So I'm up to about 25 cups of coffee. I got 25 more to go. So anyway, that's all the fun part. But you know, the idea here is that we're talking about, well, how much exposure is going to cause an adverse effect? What's an adverse effect? How do we calculate exposure? All this sort of thing. Bring it all together in a systematic way so that people can understand what you're talking about. I'd have to say, right, Andrew, that when you're talking about communication of risk, this is a pretty good way of doing it. So can we do a better job as toxicologists and risk assessors, nutritionists, in conveying human safety in a systematic and easy to understand way? So let's go back into what risk assessment has been over the last 30, 40 years. And it starts with the National Research Council in 1983. And they identified hazard assessment, dose response, exposure assessment, and risk characterization. Mike Dorson is sitting there going, oh my God, I've seen this for 40 years. I can't stand it anymore. Well, that went directly into a way, and this you can find right in that 1983 document, on how we go about hazard assessment, dose response, and exposure assessment in ways of characterizing risk. And on the front end of that, of course, there's a tremendous amount of research that goes into producing the information that goes into that characterization. And finally, there's a risk management or risk communication phase to that. Well, this is what we do in the pesticide world. We go through tremendous amount of animals, money, time, effort, doing tremendous number of studies. And this is an example of a variety of different endpoints. You can see them on the bottom. Rat teratology studies, 90-day rat study, 2-year mouse study, dog studies, and so on and so forth. And we cull through that information, and we look for a no effect level. After thousands and thousands of animals and time and so forth, we come up with one number. And it may be nothing other than weight loss in animals. And we try and extrapolate that to humans. That's what has been happening over time. And we identify that as a toxicology endpoint, throw an uncertainty factor on it because these are animals after all, and we're talking about humans. So after all of that effort in identifying that one number, we divide by 100, and we come up with something called a reference dose, which is the toxicity endpoint divided by the uncertainty factor. Good, we're done, we're out of here, right? Well, the question is, how much are you actually exposed to? So human exposure might very well, and hopefully is well below that level. That's the traditional risk assessment paradigm that we go about. Toxicity endpoint, uncertainty factor, and oh, by the way, are people actually exposed and to how much? So exposure typically is what I call the red-haired stepchild of risk assessment. We spend time, money, and effort on doing lots of toxicology and very little on exposure estimate. And the fact of the matter is that risk is not proportional to hazard. That, unfortunately, is the system that the European Union is using, typically, in identifying an adverse effect and classifying on that basis, with no true risk assessment involved, no exposure assessment. And in fact, that's tipped the scales towards doing lots of toxicology, and oh, by the way, we'll do exposure. So we want a paradigm shift in that risk assessment methodology from going from that hazard-based sort of analysis to one that's much more focused on bringing together exposure and toxicology. Late in the 2000s, there were 3 reports that came out from the National Academy of Sciences that really heralded a new change in how we go about toxicology, risk assessment, and exposure science. And these are documents well worth spending time with. But what they did was deliver a clarion call to those of us in the risk assessment community to say, you got to get it right. You got to get your toxicology better, you got to get your exposure better, and you better bring it together in a better fashion. That's far more comprehensive, systematic, as Paul was talking about, and that you can communicate that risk in a very clear and unambiguous way. So about 4 years ago, we came together as a HESI group, 120 people from 15 nations. We've got 12 companies that support it. We've got 2 NGOs involved. And over those 4 years, we came up with a systematic approach that I'm going to show you very, very quickly. And that system that I'm going to show you is actually on a 2-sided sheet that's actually at the front there. I think, Michelle, you've put that up in the, at the registration desk. So I'm going to go through this at lightning speed. Now, normally when we give the talk, I've given the talk to the European Chemicals Association. FDA CIFSAN had us in to talk about this. I've given the talk at EPA, a variety of different places. And it takes about 3.5 hours to actually go through the whole thing. I'm going to do it in about 3 minutes. Okay, so hold on to your seats. So this is the system. It's a 4-stage system. It starts with problem formulation. And in fact, that was one of the first things that the people in that group of HESI individuals decided, is that we are not doing a very good job of first thinking about what we need to know and how you know when you're done. You have to do problem formulation. If you look in the literature and look for problem formulation, unfortunately, there's not much there. So we have created some essential features about what risk or what problem formulation is all about. What do you need to know? What do you want to know? And what do you already know? Take advantage of the information you already have. Step number 2, we don't go to toxicology first. We go to exposure first. How much are people actually exposed to? And you can see these, the exposure triangle and up above it, the toxicity triangle, are actually inverted. And what that means is that at the very bottom, you're expending very little resource and very little effort to get as much information as you need. As you need more information, you work up that tiered system. So for example, in exposure, you start with minimal information, essentially a guess. And then you work on to models that are deterministic, probabilistic, and then perhaps biomonitoring. Toxicology, the 3rd step, is the same way. You start with things like quantitative structure-activity relationships, the TTC, which I know you're familiar with. Working on your way up that tier structure through in vitro testing and in vivo testing, all the way through mode of action. And here's where an interesting risk communication feature comes in the 4th step. You take that exposure and toxicology information and bring it together into what we call the matrix. The matrix is comprised of a 2-dimensional graph. And let me step you through that. On the x-axis, you can see it's the estimate of human exposure in whatever units you happen to agree to. The y-axis is inverted. And the reason for that is that typically we think of things as high toxicity, but they have low numbers. So that's why it's an inverted scale. This is a logarithmic scale, a log-log scale here. That's the other thing. And on top of that, what you're looking at is units that have to be the same on the x and the y axis. So if you've got parts per million in the air for exposure, your toxicology study should reflect that in parts per million in your animal studies. Likewise, if you're doing an in vitro study, and you've got toxicology values in micrograms per liter, you should have that the x-axis represent that in micrograms per liter. Blood concentration, tissue concentration, so like for like. The other feature on here, you can see it goes from green to yellow to red. When you bring together the estimate of exposure and the estimate of toxicity, it comes together in a fashion that gives you some indication of where you are in relative proportion to exposure and toxicity. In the green area, good. Red area, bad. Okay? Very easy to see. So it's a risk communication tool as well. So you put down exposure range, toxicity range, bring them together, and what that shows you, oops, I went a little bit too fast there, brings it together into a box that gives you an idea of what the relative toxicity or margin of exposure is. All this is explained in this nice little handout for you. Now, what we have done as well is publish this information. Oh, by the way, what happens is if you take a look at different kinds of chemicals or exposure scenarios, it looks like this. A would be in the good area, E would be in a not good area, and so on and so forth. It also tells you where your research could go. If you look at B, for example, you have a very good estimate of exposure, very tight, but not very good on the toxicology. You would focus your effort on the toxicology. F, I'll let you make the decision on what you do there. Okay? On top of that, what we've done is published all this. So we've got 3 publications coming out very soon. There's about 10 publications overall that we're doing that include 2 case studies and some work on cumulative risk assessment. So how many things go into your food and how do they interact and what's the toxicological exposure and risk assessment paradigm there. So that's a breeze through it. These are the publications that are coming out in critical reviews in toxicology right now. They'll be out in the next week in print. These are the overview papers. There's also one that delves deeply into mode of action and takes mode of action to the next level. All that is what we have done in providing a tool, hopefully, that will give you an idea of what we can do in a systematic review. We haven't stopped with publications. You can see Michelle here, her smiling face, talking about roadmap for risk assessment. We're going into the public literature as well, letting people know that there is a systematic way of going about this. We also have a web-based tool to do this. This web-based tool, as you can see here, is a problem formulation based. You can see that in the left-hand side. I can't quite point at it from here. You see in the left-hand side problem formulation. You can actually put that in there. The next drop-down box is the graph properties. You can put in your exposure and toxicology information, and it will come together on this grid in the fashion that I just showed you in the example. We've done a number of different examples in trying that out. Formaldehyde is one of them, and to do it just very quickly, let me show you how we went about it. But first of all, the problem formulation to this is that this is not a proclamation on formaldehyde at all. All it is it's a demonstration of how you use this tool. And the tool is actually looking at various values that NCEA had for formaldehyde and previous values, just looking at how it looks on the matrix. So you look at exposure from 0.2 to 20 parts per billion. You look at estimates of toxicity from, as you can see here on the graph, how that comes together on the exposure and toxicology is this way. It's a very simple way of going about putting in your information. And it tells you something about, are you in the green area, the yellow area, or are you in the red area? You can also take a look at various applications and different ways of looking at degrees of toxicity and the endpoints that you use. You can look at different degrees of exposure. You can look at the young, you can look at the old, you can look at LD50, you can look at long-term studies. It all comes together in a very visual, transparent way. And that's the whole point. So coming back to caffeine, I love to come back to caffeine. We as toxicologists look at it from an animal study. So Tony, here's your animal study, right? And you can see the disclaimer down at the bottom. This is just a quick web search. This is, again, looking at how we would go about this in a RISK21 fashion. We look at the endpoints for toxicity, and you see that it's about 30 milligrams per kilogram. We slap a 100-fold safety factor on that, and that's what we use as our reference dose. But in humans, we know that from between 0.7 all the way up through about 17 milligrams per kilogram, you can get various forms of, I guess you'd call it toxicity. Jitter, nausea, and panic. Is that an adverse effect? I'd have to say that. I don't know. Sometimes I want a little anxiety and unsteadiness to keep me on my edge. Seizures I definitely don't want. So it kind of asks the question about what is an adverse effect? We certainly know that lethality is an adverse effect, and we know what those values are in the human context. We also made an estimate of what exposure would be, and I know this is probably an underestimate, actually, now that I've looked at Peet's Coffee and what Starbucks has in there, and you as nutritionists know better than I do that 100 milligrams of caffeine per cup is probably a fairly slight amount. I think I saw the venti amount for Starbucks at about 300. That's a lot of caffeine. So if you take those two together, all right, so this is typically what you'll see in a risk assessment is a lot of numbers, but what we did is we took it together and we put it into the RISK21 Matrix, and what you see here is the animal studies are lined up in that purplish box. Yeah, it does come across as purple. And that's the 30 milligram per kilogram divided by 100. That's typically what we would do in the world of chemicals, is take that number and divide by 100, and we would say that that's the limit that we would want to have people exposed to. You can also see on there anxiety and steadiness and jitters, nausea and panic. You can also see the degree of exposure that we've put on the scale there. So easy to see that as you move up in the exposure realm, you're starting to get into that red area. But for the most part, it stays into the yellow and the green. So this is a very visual way of showing some very complex information in a way that kind of beats out that caffeine informer and death by caffeine. However, his values are down there at the bottom. You can see the human lethal dose, which is about 150 thereabouts, and you can see the amount of coffee that you would have to consume. So there you have myself drinking a lot of caffeine in a cup of coffee. I've got a long ways to go before I get into a lethality area. However, that powdered caffeine, you can see it down there on the right, that's only 1 to 2 teaspoons. That's well into the yellow area. And it wouldn't take a whole lot more to get into the red area. And that's why there are actually deaths that have occurred from that powdered caffeine. So I've given you a whirlwind tour of the previous way of doing risk assessment going back to 1983 and perhaps before, how that's been modified over time and how RISK21 has taken that to the next stage. It's a problem formulation-based, exposure-driven paradigm that's transparent, takes advantage of information you already have, and presents it in a very, very visual fashion. And we hope that this is a systematic way, as Paul was talking about, that you can apply that actually to your nutritional studies and have a very visual way of presenting the information so that you can make decisions that are easily understood. Thank you very much.